Let's look at combinations. And I hope you're hungry because we're starting at the Bauer Power Breakfast Buffet. There's 10 items on the buffet. You can get a hash brown, cereal, a muffin, a bowl of fruit, a donut, pancakes, and there's a lot of them, yogurt, scrambled eggs, waffles, French toast. It looks like we have 10 items at the Bauer Power Breakfast Buffet. You get to choose 4 of them. So there are 10 items there. We get to choose 4. Well, a couple people already have. We have this lavender plate filled with breakfast items and this green plate filled with breakfast items. On the lavender plate, we have pancakes, scrambled eggs, yogurt, and fruit. On the green plate, we have yogurt, fruit, scrambled eggs, and pancakes. These are the same meals. They are the same combinations. For combinations, it doesn't matter what order we selected the items. It doesn't matter if the lavender person picked the pancakes first and the green person picked the pancakes last. They have the same meal. It doesn't matter what order it was picked. For permutations, the order does matter. It's all about organizing things in order. But combinations, the order doesn't matter. And for this breakfast buffet, when you fill your plate, it doesn't matter what you picked first. It doesn't matter what you picked last. You're going to eat them all anyway. These two meals, the purple one and the green one, are the same combinations. They are the same meals. So again, the order of selection does not matter for combinations. It does for permutations, but not for combinations. So we don't know what order these got picked in, and it doesn't matter. They are the same combination. Well, maybe we want to advertise the Bauer Power Breakfast Buffet. How many total combinations are there? Well, we have 10 total items, and we need to find how many combinations of 4 items are possible. Well, just as we had NPR for permutations, we have NCR to help us with combinations. Once again, N is the total number of distinct different objects, and we have 10 of them in our problem. R is the number of objects we are taking, and we are going to take exactly 4 items. So our setup looks like this. And your calculators, if they had NPR, they're going to have NCR. Probably you're going to have to enter 10 followed by NCR and then 4 for your calculator to give you the answer to this problem, which is 210. If you have a TI-30X2S, press the PRB button. You'll see the choices you've seen earlier, and NCR will be the second choice. On some calculators, you'll press NCR, and then you'll have to enter in what we call 2 arguments separated by commas. So you might want to pause the video to practice with your scientific calculator to make sure you can take NCR with 10C4 and get your calculator to give you 210. Here's what your calculator is doing for you. We have 10 total items, so we have 10 factorial on top. We're taking 4 objects, so we have 4 factorial on the bottom along with 6 factorial. 10 minus 4 is 6 factorial, and that's how we do NCR. If this had been NPR, we would need 10 factorial over 6 factorial, which is 10 minus 4. We have 10 items and we need 4. But for NCR, we have 10 factorial on top, the 4 factorial on the bottom, and 10 minus 4 is 6. That's there on the bottom. If we want to write out the expansion of these things, I can write out 10 factorial as 10 times 9 times 8 times 7 times 6. And I can go on times 5 times 4 times, but I notice there's already a 6 factorial on the bottom. So I'm just going to stop right here because I know I'm going to be able to reduce them away. So the bottom, I'll write out the smaller factorial, 4 times 3 times 2 times 1 times 6 factorial. The 6's reduce out, 2 times 4 is 8, 9 divided by 3 is 3, and 10 times 3 times 7 is 210. That's what your calculator is doing for you with NCR. Okay, you try this one. How many different combinations of 11 people can be selected from the 16-member student council to set up the end-of-school cookout? Pause the video and give this a try. Here's your NCR setup. There are 16 people on the student council, and we're going to choose 11 of them. And it doesn't matter what order they get selected. If you're on the committee to set up the end-of-school cookout, you're showing up. It doesn't matter if you were the first name selected or the last name selected. Everybody's showing up. Going the long way, this is 16 factorial over the 11 factorial, and a 16 minus 11 is 5 factorial because it's NCR. And you can expand out. I'll stop at 11 factorial so I can reduce it away. But of course, your calculator can do a lot of this work for you if it has an NCR button and get this answer, 4,368 different combinations to get kids to set up the end of school cookout.